Garcia. This is my presentation on how backward walking may affect metabolic expenditure in normal healthy adults. Keep in mind these terminology: blood lactate concentration and energy expenditure. Walking is a low impact activity where one foot is always in contact with the ground. Backward walking is just walking in reverse. Is not very common, usually used in short burst training and rehabilitation. In rehabilitation, they use it to treat balance and gait and lower extremity injuries. The lower extremity injuries are treated due to the research found that it decreases force absorption of the ACL and reduces compression forces of the patellofemoral joint. But walking is typically recommended utilizing the ACSM guidelines for the cardiovascular health benefits. So there are studies that have looked into the cardiovascular and the metabolic expenditure benefits, comparing the results between backward locomotion and forward locomotion. So how does backward locomotion affect a healthy adult? First, we're going to look at the study on enhancing obesity management so we can get a better understanding on how it affects normal adults. In this study, they took 28 sedentary males to test for different responses utilizing two different treadmill speeds. And with the increase in speed, they found increased levels of lactic acid, and they were saying how they were more exhausted when walking backward at these higher speeds. And with the electromyography, they were able to determine that higher muscle activation in the anterior tibialis and the hamstring muscles are common with backward walking, and they had higher perceived exertion. So this study was very consistent with prior research, and this figure is showing you how that lactic acid does increase with the backward walking and compared to the forward walking at higher speeds. But at 3 kilometers per hour, there wasn't a significant difference compared to the 4 kilometers per hour. And for healthy adults, they determined that these metabolic and cardiorespiratory demands do increase with elevations at 0% and 5%, not just the different speeds. And they said that there is an increase in the heart rate and the oxygen uptake and suggests that backward walking utilizes an increased stride frequency because of the decreased stride length that may be responsible for the metabolic expenditure. So we're constantly changing our stride frequency and our stride lengths to essentially combat not being able to see what we're looking at. And a similar research shares similar results for the transition speed from backward walking and running. In Table D of Figure 1, there is a higher metabolic cost at speeds of 6 kilometers per hour, but there is no significant difference once we hit 7.5 kilometers per hour. So in conclusion, these studies were able to determine that backward walking does exert more energy to meet both cardiorespiratory and metabolic demands with sedentary adults, but also healthy adults. And thinking this way, we can utilize backward walking on treadmills at higher elevations to get that cardio in. We can use it for rehabilitation purposes. And here are my references. Thank you for coming to my TED Talk. Not really a TED Talk.